Hello, everybody. Welcome back. It's Mo again. Well, in this lecture, we're going to be looking at this dynamic routing. As you notice in our previous lectures, we did static routing. In other words, whatever networks I'm actually missing, I have to add them in manually. That's a lot of work, but it's the most secure way of routing. So, what I want to do over here is let me just get a few routers. Let's say one, two, three, let's say four routers. All right. And check this out. So what I'm going to do is I'm just going to actually establish a connection. Let's say we have New York, we have NJ, right? So we have different states. Then we have PA, and let's say Delaware. Now let me go ahead and just add one switch over here, and let's say another switch right over here. Okay, let me put the actual cables first of all. So I'm going to go ahead and connect the crossover cables. Let's say gigabit 00 to gigabit 00, gigabit 01 to gigabit 01, and gigabit 02, let's say to gigabit 02. And then I'll put straight through cables from gigabit 01, let's say to gigabit 01, and same thing on this one over here. So I'm going to put a straight through cable from gigabit 01 to gigabit 01. Let's just add one device over here, one laptop, and let's say we have a server right over here. And let me establish a connection. Of course, straight through cables port one, and this one goes to port one. All right. So what I'm going to do is let me just put the networks first. So these are public IPs 210, 210, 210.0/30. And this one is actually what 211.211.211.0/30 and 212.212.212.0/30. And we have private networks on the internal here. Let's say this one is the 100.0/24, and this one is the 192.168.200.0/24. Of course, all the interfaces are down. How many broadcast domains do we have? We have one, we have two, three, four, five broadcast domains, and six, seven collision domains. I like to go ahead and do the port label so I can see which ports are actually belong to which. So let me go to each router and just change the IP addresses and the host names first. And we'll look into more dynamic routing. There's RIP, there's EIGRP, and there's OSPF, and we're going to be talking about RIP first, which means this works on any vendor, which means it could be Cisco and non-Cisco. Now, the problem with the RIP itself, it does by default a broadcast because there's two versions. There's version one and two, where version two does a multicast. And RIP version one does not support classless networks, which means I cannot do with subnetting, where RIP version two does classless networks, but the administrative distance of RIP is 120 and OSPF is 110 and EIGRP is 90. RIP and OSPF, they work on any vendor where EIGRP only works on Cisco products. So we're going to see lots of differences with dynamic routing. So let me just go ahead and configure an actual host name. So let's say host name is New York, and let me go to interface gigabit 0/1, no shut, and give this 100.254. So 192.168.100.254 space the default mask, right? And then interface gigabit 0/0, right? And no shut. And this one will be, let's say, 210.1. So 210.210.210.1 space 255.255.255.252. And I'm going to go ahead and do WR so I could save my configuration. And then I'm going to go to NJ. Let's take a look and see NJ itself. So first of all, let me just change the host name. Host name is NJ. And let's say interface gigabit 0/0, no shut. And now you'll see the interface is up, right? And this one is 210.210.210.2, 255, 2F5 what? 252, right? And interface, what's the next one? Which is gigabit 01, right? That's a 211 gigabit 0/1. So I'm going to say interface gigabit 0/1, no shut, and give it an IP address as 211.211, right? .211.211.1 with a what? 252 because it's a /30, all right? Okay, so very good. And I'm going to do WR. So I just finished NY and NJ, just putting IPs right now. Pennsylvania will have two interfaces, right? Let's take a look and see. So let's say host name is PA, and then interface, let's say gigabit 0/1, no shut. And this is 211.211.211.2. So 211.211.211.2, 255.255.255.252. And of course, we're going to be looking at gigabit 0 slash what? 2. So gigabit 0/2, no shut. And this is what? 212.212.212.212. Dot what? Dot 1 with a 252, right? And of course, I did the no shut and I could do WR. Now we're going to our last router, which is Delaware. So I'm going to go to the CLI and go to Delaware. So let me just change the host name on this one, host name DE, right? And this has interface gigabit 0/2, no shut. And you'll notice the interface is up, all right? So this one is 212.212.212.2. 255.255.252. And also interface gigabit 0/1, no shut, and this one will be 200.254, 192.168, 200.254, 255, 255, 255.0, and then I'm going to do a WR. So everything looks good in terms of IPs. Why not put IPs on the actual laptops? All right. So this one will be 100.100, 192.168, 100.100, and this one will be 100.254. I don't need DNS. And this one will be 200.100, right? So this one is 200.100, right? So let me just go ahead and do the following. I like to use 254 as the last number. It's just a habit, or you could use like the first available number. It could be dot one or 254. So, of course, at the moment, let me get rid of the port labels. Let me remove port labels here. This laptop cannot reach the actual server. Watch this. So if I try 200.100 from here, ping, let's say with a negative T, 200.100, right? It's going to fail. Unreachable. Why? Because look at this. What does New York router support? Only supports whatever is physically connected to it. So if I do show IP route connected, I see the 100 and the what? And the 210. If I do show IP protocols, this tells me if I'm running dynamic routing or not. Now, dynamic routing is the opposite of static routing. Static routing is like I have to add the networks that I'm missing. Dynamic routing, you advertise your networks to the neighbors, like what you actually support. And at the beginning, I'm going to use RIP. And guess what? I'm going to be looking at RIP version 1 and RIP version 2 so you can see the differences between them. So at the moment, each router only supports whatever it's actually physically connected to. So if I do show IP route connected, I only see whatever I'm connected to. Same thing with Pennsylvania, right? So if I do show IP route connected, I only see whatever I'm connected to. And same thing with what? With Delaware, show IP route connected, I only see whatever is actually connected to. So I'm only connected to the ones that I have a physical connection, which means Delaware cannot reach anything else. Like New York, if I try to go ahead and ping, like New York can only reach the 100 and the 210. So if I open New York and I say, you know what, can you ping 210.210.210.2? Yes, I should be able to ping that, right? But I cannot reach the 211 ping because my router does not support that network, right? So it's going to fail. I only support whatever I'm actually physically connected to. And I don't want to do static routing. I want to do dynamic routing. So let's see how dynamic routing actually works. How does it work? First of all, I'm going to use RIP. And guess what? Every time we pass through a router, what is that called? A hop. And guess what? RIP only goes up to 15 hops. And let's take a look. So first of all, I like to do show IP route connected. Now watch this. Config T, router, space, question mark. And I can see RIP, OSPF, EIGRP, and there's what? BGP. Now, when it comes up to dynamic routing, there's IGP protocols and EGP. IGP is Interior Gateway Protocol, which means within the same company, but in different locations. EGP is only done by the ISP. And the only example of an EGP, exterior gateway protocol, is what? BGP. So when we look at RIP and OSPF and EIGRP, these are IGP protocols, interior gateway protocol for the same organization, but they're actually in different what? Physical locations, different sites, right? So watch this. I want to do RIP first and question mark, nothing, enter. Let me ask for help. So, what do I do over here? Okay, what are my networks? The 100 and the 210. So I advertise my networks, the 100 and the 210. So I'm going to say network 192.168.100.0 space question mark, nothing, and the 210, 210.210.210.0. Just like this. And I'm going to do version one first. All right. So I'm just running, there's two versions. If I do version question mark, it's either one or two, and we'll see what the distance command does also. All right, so let me do WR on this router. Let me go to New Jersey and do the same thing. So I physically support the 210 and the 211. So I'm going to go to global configuration mode, router RIP of version one, and advertise the networks that I physically support. And which one? And the 211. So you advertise what you actually support. That's what you advertise. So it's the opposite of static routing. And do WR. And I'm going to go to Pennsylvania and do the same thing. So config T, router RIP, version one, the network command 211, 211, 211.0, and also what? 212.212.212. What? Dot zero. And then do WR. There you go. And last one, Delaware. And look at this. So far, this machine is not reaching, right? Okay. Watch what's going to happen when I go to Delaware. Watch this. Global configuration mode, router RIP, right? So router space RIP. And then I could do the network command first or the version. It doesn't really matter, folks. 200.0. And then the network, what? 212, 212, 212.0. And I could say version what? One and WR. Okay, very good. Let me take a look. And guess what? I'm going to be waiting for like 30 seconds. Watch this. And I'll explain why. Where does the 30 seconds come from? So let's give it a few seconds. And I should be able to reach. There you go. I could reach from source to destination. Perfect. Guess what, folks? Let me do a trace. So I was able to ping 200.100. Let me do a tracer 200.100 and see the path. Look what it's going through. It's going through all the routers. These are hops. So it's going through one hop, two, three, four hops. All right. This is the IP address of the server. So it's going like from here to this interface to this, two hops, three, four hops. RIP can only go up to 15 hops. So it's only for small networks. So I was able to reach from one side to another. Well, guess what? If I do show IP route, I could see the letter R for RIP. You see that? Letter R. 120 is administrative distance. Remember, static is one. So RIP is 120. And what is this number here? How many hops it takes to reach to get to the 200 network. See, this is one hop, two hop, three hops. As you see, I could do show IP, route, RIP, and I could see this is what I actually have. And it tells me that the problem that I have right now, it doesn't look at it as a slash 30. Do you see what it's doing? It's a slash 24. And this is incorrect. It should be a slash 30. And why? Because I did version one. Version one does not support classless routes. It summarizes the subnet mask. It goes back to the default. Well, guess what? If I do show IP protocols, oh, there we go. That's what I'm talking about. It sends updates every 30 seconds. To who? To everybody. Now, guess what? If something is wrong, it takes it 180 seconds for it to be invalid. Then it's going to hold on to that for 180 seconds, and it takes 240 seconds to be removed from the routing table. That's a problem. That's a lot of waste of time. Processor of the actual router is being abused over here. And look, sending and receiving is version what? One. And which networks am I actually advertising? Who's my neighbor? Administrative distance of RIP is 120, and it sends updates every 30 seconds. Administrative distance, the default is 120. Well, how can I prove to you that RIP version 1 does a broadcast? I could use something called the debug. Debug IP space RIP. And check this out, receiving updates. And look, sending updates to the broadcast every 30 seconds. You see that? That's a lot of waste of traffic. That's too much abuse for the CPU and the bandwidth of the router. Okay, look at this. If I go to New Jersey, for example, and I do debug IP rip, debug IP rip. Okay, so it's going to be sending a broadcast via both interfaces, via gigabit 01, you see that? And gigabit 00, a broadcast. It's like every 30 seconds, you're shouting to everybody, this is what I support. Now, that's not a good thing. This is the problem with RIP version 1. So, what we're going to do is, in our next lecture, we're going to compare RIP version 1 with RIP version 2. So, we'll see you folks in our next lecture. Bye now. Hello, everybody. Welcome back. It's Mo again. Well, this lecture we're going to look at is RIP version 2 because there's no way we'll ever work with RIP version 1, especially with a classless environment, because we saw that it doesn't support that. So watch this. Look at this. When I go back to New York, and let me stop the debug so I could do Control A and say no debug IP rip. So it doesn't do this anymore. So watch this. So when I look at my configuration, show run, I can see that I'm running RIP and it's version 1 and it's advertising these networks. So what I actually need to do is what? I need to go ahead and apply RIP version 2. So RIP version 1 is not something that you'll ever actually use because with today, a point-to-point connection is going to be a slash 30. Remember that from our subnetting class? We don't want to be abusing IP addresses. So watch this. So when I do show IP route right now, I can see that I'm running RIP at the moment, and it's everything is a slash 24. So this is not a good thing. Of course not. Administrative distance still 120, and this is like how many hops? So what I need to do is I'm going to go back to global configuration mode, router RIP, and I'm going to do version 2. And guess what? There's another command that I have to run, which is the auto summary. Disable the auto summary. Do not summarize the subnet mask. Why? If I leave that, it's going to still go back to a slash what? 24. All right. So do WR. So I'm going to go to each router, do version 2. See, now it says ignored version 2 because it's an illegal version. The version is a mismatch. Okay. So watch this config T, router rip. Okay. Version 2, and then no auto summary and do WR. See that? Okay, now I want to do, if there's a debug, I could soon no IP debug, let's say no IP debug rip, right? So watch this, or I could say undebug all in case there's a lot of debugging. Okay, so I already did New Jersey. Let me go to Pennsylvania and do the same thing. So version 2 and no auto summary. See that? And then do WR. And same thing, I'm going to go to Delaware and I'm going to do version 2. Watch this. So version router RIP, I have to be in the RIP mode, version 2, and then no auto summary, and then do WR, just like this. So I'm going to do a Control Z. And this time, when I do show run, take a look at this. I see version 2 and no auto summary. So this is something I would say if you're ever configuring a RIP, which is something I won't advise, but it's good to see version 2 and no auto summary. So what I'm going to do right now is go IP protocols, and I could see that I'm sending and receiving version 2. You see that? Still, the timers are still the same. Guess what's the difference? Instead of broadcasting to everybody, it does a multicast, which means multicast is what? It just talks to the neighbors. So it's less bandwidth and CPU utilization on the router. So if I do a debug IP rip over here, watch this. Give it a few seconds. It's not going to be sending a broadcast to everybody. It's going to be doing a multicast to the neighbors. Now, look, this is still a receiving. This is not a problem. I'm looking for the sending. So when it says sending, it's going to send to the multicast address of RIP, and it's what? 224.0.0.9. That's a class D. Remember from the TCP/IP class that you actually watched in our previous section? So this is the actual address for RIP version 2. So if I go to any router, watch this, and I do debug IP rip, and I go, let's say, to this router over here, New York, and I say debug IP rip. I just want to prove this first, debug IP rip. It's only going to be doing a multicast, which means just to the neighbors, instead of a broadcast. That's way better than what we had earlier with RIP version 1, which was doing an actual what, folks? Broadcast, right? So this is much better for us. Okay, so this is a good thing. So what I want to show you is the following: undebug all. And if I do show IP route rip, look what I see. Now I see the /30 because I did no auto summary. And look, possibly down, this is going to be removed. You see that? But it takes 240 seconds. What I could do is instead of waiting for 240 seconds, I could do a clear IP route asterisk, then show IP route rip and give it another 30 seconds, and it's going to build up. So I could do clear IP route asterisk on each router to remove the bad ones, which is the actual what? The /24. Undebug all. Oh, it looks like I typed it wrong. Okay, undebug all. So debugging is off. Then what I'm going to do is clear IP route asterisk, right? So I'm doing this on every actual router to refresh the routing table. So I don't have to wait for 240 seconds. Clear IP route asterisk. All right. And last router, Delaware. I'm going to do the same thing. Let me first do undebug all and then clear IP route asterisk. Now I'm actually done with everything, right? So that's one thing to keep in mind. So now I go back to New York. Watch this. So IP route. And now look, I'm going to see the /30. So if I do show IP route, rip again, see that? The /30. So it tells me that this is subnetted, but I don't see the /24 anymore. So this is accurate information. As you see, so IP protocols will be the same, right? Except that I'm going to see sending and receiving version 2. All right. Okay. Well, can this machine connect to the server? Yes, it can. Let's see. If I try to trace, same thing, I could reach. If I try to ping, I could reach. So I could reach from one side to what? To another. This is RIP version 2. That's what I wanted to show you in this lecture. There's one more thing that I wanted to show you. When I configure RIP, RIP will advertise through both interfaces. See that? Well, let's say this. Do I need to advertise through this interface? No. You know why? Because I don't need to notify neighbors. There's no other routers. So there's a command that is called the passive interface where I apply it on this interface over here. Why? Because I don't want this interface to advertise. If I open New York and I say, you know what? Debug IP rip. Now let's see if it's going to advertise through both. Look, options, preferences, and show port labels, right? And let's take a look. So this is gigabit 01. Watch this. Let's give it a few seconds, folks, and you'll see what I mean by this. 30 seconds. There you go. So sending updates. Look, sending updates also via gigabit 01. But why would I need to do this? I need to make sure I could put a pause over here because this router is only hooked up to a switch. So what do I do? Let me stop the debug. So no, debug IP rip. Watch this. I go to router rip and I do the passive interface command for gigabit what? 0/1. Just like that. And I do the same thing on Delaware. Config T, interface, router rip, right? And passive interface gigabit 0/1. So I put a passive interface on gigabit 0/1. Why? Because I don't want this router to advertise. Why? It's hooked up to a switch. This router is hooked up to a switch. I only need to do it on the interfaces are actually hooked up to switches, which means they don't travel to the outside. See, I didn't have to do anything on New Jersey and what? Pennsylvania. So if I go back to this router, New York, and I say, guess what? Let's do a debug IP rip again. And it's not going to be sending updates via gigabit 0/1 anymore. And if I check Delaware and I do the same thing, debug IP space rip. And let's take a look and see both of them. So sending updates via gigabit 00. You see that? It's not going to say sending updates via gigabit 01. It's not going to see that in the list because I did a passive interface. Let's give this a moment, folks, so you can see. Members doing this every 30 seconds. What's good about version 2? It does a multicast, which means it just does it to the neighbors. Let's see. See that? Nothing about gigabit 01 because I did a passive interface. And guess what? That's what you need to do when you have a router such as New York and Delaware where it's just hooked up to the internal. So if I had Pennsylvania and there was a switch over here, I would do the same thing on that interface. And if I check this one out, I don't see gigabit 01. It's not in the list because of that interesting command, which is the passive interface. All right, so understand this. RIP only goes up to 15 hops. Version 2 does what multicast. Version 1 does a broadcast. The administrative distance of RIP is 120. And then I have to put passive interfaces on the ones that are not hooked up, let's say, from router to router. That's what I wanted to show you in this lecture. In our next lecture, we'll be looking at OSPF and we'll be seeing EIGRP. So this is one of the first dynamic routing protocols which works on any vendor. So we'll see you folks in our next lecture. Bye now. Hello, everybody. Welcome back. It's Mo again. Well, in this section, what we're going to be looking at is how to work with OSPF. As you saw in our previous section, we worked with RIP, Routing Information Protocol. The administrative distance is 120. It only goes up to 15 hops. We had RIP version 1, RIP version 2. Version 1 is only for classful, where version 2 is classful and classless. RIP, on the other hand, works with any vendor, Cisco and non-Cisco routers. Guess what? OSPF is the same guess. It works on Cisco and non-Cisco routers where the administrative distance is 110. But what's good about OSPF is it calculates the best route based on minimum bandwidth. RIP looks like distance, which is minimum hops, where OSPF is actually based on what's better in terms of the speed of the lines themselves. And there's no limitation of how many hops OSPF actually supports. So let's take a look at this. Let me set up an actual simulation here. So I'm going to get a few routers. Let's say 4, 5, 6 routers. All right. So it's going to take us a while to actually set up these actual interfaces, but it's worth, and you'll see what I'm actually talking about. So let's say, for example, this one over here is actually New York. We got this one as NJ. We got this one as PA. We got this one as Delaware. We got this one as Virginia. And let's say we got this one as what? I think we skipped an actual state, right? No. After Delaware, we have what? Maryland. And then we got what? Virginia. Okay, so let's say we got these actual states. So let me connect the actual lines. Before I do that, I'm going to put a switch over here on this side and a switch right over here. All right, so let me make the actual connections. So let me go ahead and make the connections. Of course, we're going to be using a what? Straight through cable going from where? From the switch to the router. And same thing right over here from the switch to the router. Now, of course, I'm using what? Crossover cables. So gigabit 01 right over here to gigabit, let's say 00. And I have gigabit 01 right over here to gigabit 01. Let's say gigabit 00 to gigabit 00, gigabit 01 to gigabit 01, and gigabit 00, let's say to gigabit 01. So first of all, I want to prove how RIP and OSPF works, and I'll show you the bandwidth. So I'm going to get one PC over here, and let's say we have a server right over here. All right. And let me make the actual connection. So the laptop connects to the switch, and the server connects to the switch right over here. So let's put the actual networks. Let's say this network is 192.168.100.0/24, and this is private, which is 192.168.200.0/24, right? Just like that. And now let me put the actual for the interfaces, which are the WAN links. These are public IPs, let's say 210.210.210.0/30, and this one 211.211.211.0/30. And this one over here is what? 212.212.212.0/30. And let's say this one is 213, 213, 213, right? Dot zero slash what? 30, which means it's only two available numbers. So I'm actually abusing a lot of numbers. And this is 214, 214, 214 dot zero slash 30. So this is actually fine. All right. Let me put these here and this one right over here. The first thing I like to do is I like to go to the interface itself. Let's change the actual names. Let's say global configuration mode. Host name is actually NY. Then interface gigabit 0/0. And I'm going to do a no shut. That's the one that connects to New Jersey. And I'm going to give it an IP address as 210.210.210.1 space 255.255.255.252, right? And then I'm going to go to gigabit 0/1 and do no shut. And look at this. See, the interface is going up, right? IP addresses 192.168.100.254 with the default mask, just like that. So I'm done actually with New York. So I'm going to go ahead and do what? Do WR. So then I'm going to go to NJ, right? Here's NJ. And let me just go ahead and change the host name first of all, so to NJ, and then interface gigabit 0/1. And look at this, when I do a no shut, right? So this is the one that connects actually to what? To PA, all right? So IP address is 211.211.211.1 space 255.255.255.252. And then I go to interface gigabit 00 and I do a no shut. And that's the one that connects to New York. You see how it turned green? And this is going to be what? 210, right? 210, 210.2, 255, 255, 255, dot what? Dot 252, of course. So I'm done with NJ and I'm going to do WR. All right. And then I'll go to PA, right? So here's PA. And let's take a look. So let me just change the host name to PA, then interface gigabit 0/0 and do a no shut. And that's the one that connects to where? To the next router, which is what? Delaware. That's a 212. So IP address is 212.212.212.1 space the 252 because it's a /30, right? And then I go to interface gigabit 0/1. When I do a no shut, look at the one that connects to actually NJ. See how it turned up? So IP address 211.211.211.2 space 255, 255, 255, 252. And let me do a WR. So I'm done with PA. Now we're going to go to Delaware, right? So Delaware is the next one. Let me just change the actual host name, right? So global configuration mode, host name is Delaware, interface gigabit 0/0, no shut, right? So that's the one that connects to PA. So IP address is 212, 212, 212.2, 255, 255, 255.252. Then gigabit 0/1, which is the one that connects to where? To Maryland, right? So no shut. And of course, it's not going to turn on unless I go to Maryland and do so. So this IP address is 213, 213, 213.1, space 255, 255, 255.252. Right? So this is good. And I'm going to do WR. So Delaware is actually done. Now we're going to go to Maryland. And Maryland, let me just change the host name. So global configuration host name is Maryland, interface gigabit 0/0, no shut. That's the one that connects to VA, which is IP address 214, 214, 214.1, 255, 255, 255.252. Then gigabit 0/1, no shut. That's the one that connects to Delaware. You see how it turned green? 213, 213, dot 213 dot what? Dot 2. Space 255, 255, 255, dot 252 and then do WR. So this is actually good with Maryland. And then we'll go to Virginia. Let me just change the host name. So global config mode, host name is Virginia, interface gigabit 0/0, no shut. And that's the one that connects to the switch, which is IP address 192.168.200.254, space the default mask. This is not classless, as you see. And gigabit 01 is the one that connects to where? To Maryland. So let me do a no shut, right? So It looks like the interface. Let me just remove this. I don't like that. Let me put the cable again. So gigabit 01 to gigabit 00. Okay, there you go. Sometimes the cable, you see that, folks? It's like the Cisco packet tracer. The cable's like, hello, you have to actually modify that. IP address 214. So it may happen. So don't actually panic when it comes up to that. Sorry. So this is 214, 214.2, 255, 205, 205, 252 and do WR. So I'm actually done configuring the interface. Now, if I want to see the ports, I go to Options, Preferences, and I do Show Port Label. You see this? Then I can see the ports, just like the way it is, just to show you. So if I go back to Options, Preferences, and let me remove the port labels. Let me give this an IP address as 100.100. 192.168.100.100, and the gateway, which is the IP address of the router, which is 100.254. And this will be 200.200, let's say, the actual server, right? 200.200. And the gateway is 200.254. If I try to reach 200.200, if I try to go to the command prompt and I say, you know what, ping -t to 200.200, it's not going to work. Why? Well, guess what? New York has only information about the 210 and the 100. New York cannot reach, PA cannot reach the 211, cannot reach the 212, cannot reach any of that. So if I go to New York and I say, you know what? Let me take a look at my routing table. Show IP what? Routes. And let's take a look. I only see the 100 and the 210. That's what I'm connected to. I could do show IP route connected, and I can see what I'm connected to. So New York cannot even reach this. So when this laptop connects, they only can reach whatever New York actually supports. New York can only reach the 210 and the 100. We saw that with RIP. So New York can actually ping what? Check this out. So when I looked at New York, I could see what I'm connected to. So I could ping whatever I'm connected to, which is 100.254. I could also ping 210.210.210.2, right? Which is the IP of what? I mean, I should be pinging 210.210.210.1, actually, my interface. So I cannot leave New York. I could reach myself. You see that? So that's why I need to do routing. I cannot reach the 211. So if I try to reach the 211.211.211.1, I'm not going to reach. I cannot reach anything else except whatever I'm actually physically connected to. So I maneuver the mouse over here. I can see what IP address I actually have here. I cannot reach because that's where I kick in with routing. Now, I did RIP. Now, guess what? I want to do RIP quickly, and you'll see why. All right, watch this. So, first of all, let's do this. Show IP route connected. I can see what I'm connected to. So I'm going to say router, RIP, version 2, no auto summary. And I'm going to advertise my networks, which is 100.0 and the 210 and 210.210.210. What? Not 0. Right? And plus, I like to put a passive interface right over here. Remember from the previous lab? But I'm not going to do that for the sake of this lab, just to make it much easier for us. And I'm going to go ahead and do WR, just like that. And then I'm going to go to NJ and do the same thing. Show IP route connected, right? Just like this. So first of all, I like to see what connected routes I have. All right. So, and then global configuration mode, router, RIP, version 2, and do the networks, which is 210.210.2.0. And also, is there a command that I missed? I want to see if you guys remember from our previous lab. And I should do the no auto summary command. Remember? Summarization is turned on. Nobody mentioned anything. No auto summary. And let me do WR so it doesn't summarize the subnet mask, right? And then let me go to PA and do PA. Show IP route connected. And let me advertise these networks, right? So router RIP version 2 and advertise my networks 211.211.211.0 and also 212.212.212.0. And I'm going to do no auto summary and then do WR, right? Just like this. And here's Pennsylvania. Now we're actually on Delaware. Show IP route connected. And I'm going to go ahead and do the same thing. So router rip, version 2, no auto summary, and then the network's 212.212.212.0, and then the network is 213.213.213.0. So I have these actual networks, and then I'm going to do WR. So here's Delaware, right? So PA, as you see, I advertise the networks, and now Delaware, I advertise the networks, and now I'm going to go ahead to Maryland, right? So here's Maryland. Let me do show IP route connected, right? See what I'm connected to, 213 and 214. So router RIP version 2, and then network is 213, 213, 213.0, and then network is what, 214, 214, 214.0. And then do WR. So I could save the configuration, but let me do the no auto summary and then do WR, right? So we have to make sure we always do the no auto summary and the actual networks, right? So that's actually Maryland. And the last one, Virginia. Let's see what it supports. Show IP route connected. So then let me go to global configuration mode, router rep, version 2, and then no auto summary, and then the network is 200.0, and also 214, 214, 214.0, and then WR. There we go. So right now, guess what? It's going to take 30 seconds. It should take over. So I should be able to reach from the laptop to the server. Let's give it a moment and see right now. I could fast forward, take a look. So I should be able to reach from one side to another. If not, we will check and see where it's actually failing. That's what I want to see. So if I go to New York and I say, you know what, show IP routes. All right. Let's see. I don't see RIP. That's interesting. Show run. RIP is running. Okay, 100 and 210. Everything looks good. But still, I don't see anything at all. Let's take a look. Show run. Show run, and let's see over here. Version 2, no auto summary, 210, 211, all right. And it's still not taking effect, right? Something is missing. Something is missing. Let me see. How come this one? How about when I do show IP protocols? Do I see the networks? Yes, I do see the networks. Show run. Let me see my IPs. 100.254, 210, 210, 210.1. This one looks good. Still not reaching, right? So I still see something is actually down. Gigabit 00, this is 210, okay. Let me see NJ, 210, 210, 210.2, and 211. Something is probably on New Jersey. Show run. Let's take a look. Version 2, the network's 210 and 211. And I have no auto summary. Okay. How about if I do show IP route? Okay, it's updating little by little. As you see, it's actually updating. They just actually kicked in. Let me take a look and see over here if this one kicked in too. Show IP route. No. See, something is wrong on this side over here. This is good for troubleshooting. Let me just look at the port labels. And this one is 00. This is 01. Okay, let's see 01. 01. Oh, look, I reverted the IPs. Do you guys see what's happening? 01 should be the 210. There you go. I just found the problem. Okay, so what I'm going to do is interface gigabit 0/0 and do no IP address, right? And then gigabit 01 and do no IP address. And then I'm going to go to gigabit 01 and do the IP address, which is 210.210.210. What? Dot 1, 255, 255, 255.252. Then gigabit 00, and the IP address is what? 100.254. And nobody said anything. Okay, see how we troubleshoot over here? There we go. Now look how it's going to work immediately. Watch this. Command prompt. There you go. Unreachable. Okay, that's fine. Timing out. Come on, kick in. It takes 30 seconds to actually kick in. And let's make sure. There you go. We get a reply. This is beautiful. So if I do tracer space 192.168, let's say 200.200. Look at the path that it takes. It's going through all the routers. I mean, this is RIP, folks, right? This is RIP. So if I do show IP route, I could see RIP is in the list. Administrative distance is 120. Well, guess what? My next step is I need to configure OSPF. Okay, so watch this. 15, and I'm going to go ahead and configure OSPF. So this time I do router space OSPF. I have to put something called the process ID where it's significant to the local router. I'm just going to match it. Let's say 100. And this is based on bandwidth, which is the speed of the lines. And OSPF is going to take over RIP. Why? Because it has a lower administrative distance, which is 110, and RIP is running as 120. So I'm looking at RIP as a backup, which is not a good solution for now. And you'll see why, because of the bandwidth that it consumes. OSPF discovers neighbors based on something called an area which is a zone that makes two routers talk to each other and become a relationship, an adjacency, and they have to belong to the same area. If they don't belong to the same area, they will not talk to each other. So I don't have to do the actual auto summary. Auto summarization is turned off. So I have to advertise my network, which is 192.168.100.0. Now look at this wild card. What is the wild card? A wild card is the inverse of the subnet mask. Now, what does that mean when we say inverse of the subnet mask? The opposite of the subnet mask, which means if the subnet mask is 255, 255, 255.0, the wild card is the opposite, which means the 255 becomes a zero and the zero becomes a 255. Space question mark area, and they have to belong to the same area. And I'm going to do area zero, which is the backbone router, and we'll be talking more about that. Then I'm going to advertise my next network, which is 210.210.210.0. Now it wants to know the wild card. Now watch this. Let me just open a notepad file and show you something over here. So, for example, if my mask is 255, 255, 255.0, the wild card is the inverse. So the 255 becomes a zero and the zero becomes a 255. How about this? If it's 255, 255, 255.252, what is the wild card? Okay, the 255 becomes a zero, the inverse of the mask. And what is the 252? Well, how did I get a 252? Well, guess what? I used 128, 64, 32, 16, 8, and 4, right? 6 bits here. What's the value of the last bit that I borrowed? It's a 4. Take away 1, and that becomes a what? A 3. Or you know what you could do? Always the number 256, right? I mean, I could say this also, that's an old thing, minus the number that I'm going to get here. That's going to be the increment number. 256 minus 252 is a 4, and just minus 1. So this is a 3, right? So the reason why I got a 3 here, how did I get a 252? I used 6 bits, right? What's the value of the last bit that I borrowed? It's a 4. Take away 1. That's a wild card. So the wild card over here is going to be what? 0.0.0.3 space area 0, right? Just like this. And then do WR. That's New York. So because when I do show IP route now, I will see RIP. RIP is taken over because that's the only protocol that is actually running. So if I go to NJ and I do show IP route connected, I can see which ones. So let me go ahead, router, OSPF 100, and advertise the networks 210.210.210.0.0.0.3 because the jump start is what? 4, right? And then I'm going to do the network as 211.211.211.0 space 0.0.0.3 space area 0. Now look what it's going to do. It's going to find an actual neighbor. Watch. There you go. The neighbor was formed because NJ and NY belong to area 0 and adjacency was actually formed, right? And let me do WR. Now PA. You know what? Let me get rid of the ports so we can actually see better. So port labels. And let me do PA. And right over here. So show IP route connected. And let me go to global configuration mode, router, OSPF 100, then network. Let's say 212, 212, 212.0, the wildcard 00.3. Remember, the reason why I put a 3 because the jump start is a 4, and minus 1 will be the actual increment, which is a 3 for the wildcard, and area 0. And I'm going to do the network as 211, 211, 211, 211.0.0.0.3 space. They belong to the same area, which is area 0, right? Then do WR. Then Delaware. right? So if I go ahead and I do show IP route connected, I can see the networks. So router OSPF 100, then let me advertise the networks 213 dot 213.213.0.0.0.3 space area 0. And then also the 212 network 212.0.0.0.3 space area 0, just like that. And then do WR. So that's Delaware. And now Maryland, same thing. So IP route connected, and let me advertise through OSPF router, OSPF 100, and then the network, which is 214.214.0.0.0.3 space area 0, and also what? The 213.0.0.0.3 space area 0, just like that. And then do WR. If I go back to the other route, I was going to say, oh, it forms an adjacency. You see that? Virginia, same thing. And look who's going to take effect right now, OSPF. Why? Because it has a lower administrative distance, which is 110. And let me advertise this one, router space OSPF 100. And then the network is 200.0.0.0.255. See, this is a 255 because it's a slash 24. But then when I do the actual what? The 214, right? Dot 0.0.0.0.3 space area 0, just like that. Control Z, then WR. Now OSPF is taking effect. Now check this out. If I go to any router and I do show IP route, I'm not going to see RIP. RIP is going to little by little is going to be gone, right? This is going to be gone. Everything's going to be OSPF. I could go ahead and just fast forward and just take a look and see here, right? So now everything's going to be OSPF. I'm not going to see RIP. OSPF took effect. Why? Because it has a lower administrative distance. Show IP route. Look at this. No more R's. Everything is OSPF. Look at this. Show IP route. Everything is the letter O. And guess what? Can they still ping? Yes, it's still pinging over here. So if I go back and I do ping, it's going to ping. And if I do trace, it's going to be the same thing because that's what I have right now, the same path. You'll see how I'm going to be manipulating this. But as you see, if I go to any router, I'm going to have two routing protocols running, show IP protocols. Show IP protocols. Watch this. So RIP is running, which is based on a timer, but OSPF is not. The beginning, it tries to establish a neighborship, which means if you belong to the same area, let's become neighbors. And then after that, it's going to send the complete routing table. Now, if there's no actual changes, it will not bother. So as you see, we're going to be talking more about this, but I wanted to show you that OSPF is taking effect because it has a what? A lower administrative distance. That's what I wanted to show you. So OSPF is based on bandwidth. It's no timers like RIP. That's what I wanted to show you in this lecture. We're going to be having a lot of lectures about OSPF. This is the first one. So we'll see you folks in our next lecture. Bye now. All right. Hey everybody, welcome back. It's Mo again. Well, in this lecture, we're going to continue with OSPF, Open Shortest Path First. Let's talk more about it. But before we do that, you saw that in our previous lab that OSPF took over RIP because OSPF has a lower administrative distance. Well, what I need to do is maintain OSPF. So what I'm going to do over here, first of all, you remember when we said the passive interface for RIP? So I still have to have a passive interface on this interface that connects to the switch, and I should have one that connects to this switch. So SPF does not advertise this way, right? There's no reason for it because it's not connected to other routers. So my next step is the following. Let me just do the port labels. So I'm going to be doing it on gigabit 00, and on this side is going to be also gigabit what? 00. So on New York, so I should go to router OSPF 100 and put a passive interface on gigabit 0 slash what? 0. And then do WR. And I should do the same thing on where? On the last router, right? Which is Virginia. So I'm going to go to Virginia and do the same thing. Router space OSPF 100. And then I'm going to do a passive interface on gigabit what? 0 slash 0, right? Just like that, and do WR. So this is something that you must do because there's no neighbors to establish an adjacency with New York. If it's like New York to NJ, yes, but this is connected to a switch, so you always should be putting a passive interface. Now, how about this, which probably will not make sense? How about if you want RIP to win over? Well, guess what? You could lower the administrative distance of RIP to something lower than 110, or you could higher OSPF to something higher than 120. So if I go to New York, for example, just for the sake of the test, and I do show IP route, I can see that the OSPF is actually there. This is actually the cost to reach the destination, which is based on what? Bandwidth. All right. 110 is administrative distance. So if I do show IP protocols over here, right, I can see that I'm running RIP and I'm running also what? OSPF, open shortest path first. That's what it's actually running right now. But look at the administrative distance is 110. So if I go ahead and I say, you know what, router OSPF, let's say 100, then I could look for the distance command and change the distance to something higher than 120. Let's make it 121, right? Just like this and do WR. So I'm going to go to each one and change the distance to 121. So router OSPF 100, distance 121. Then do WR. And then TA and do the same thing, right? So router OSPF 100 and distance is what? 121 and do WR. That's PA and Delaware, same thing, right? Just to show you who's going to be winning the actual election. And distance is 121, right? And do WR, that's Delaware. Then we'll go to Maryland, right? Router, OSPF 100, and then distance 121, and then do WR. And then, of course, Virginia. So I could just do the actual distance from here, distance 121. All right. Now look who's going to be winning the election. So if I go to New York and I do show IP route, I'm going to see RIP winning the election. No longer OSPF because OSPF is using 121, RIP is using 120. The one with the lower will take effect in the routing table, so OSPF will be as a backup. But if I do show IP protocols, right, I can still see RIP is running, and of course OSPF is running. But right now, RIP is taking effect, is taking over the election because it has a lower administrative distance than OSPF. And of course, I could switch that and make OSPF win. I want to have a different setup for our next lab just to actually show you how really OSPF works. And I'm going to prove a point that it's actually based on bandwidth, not hops. Over here, I cannot see because when this laptop wants to reach this server, there's only one path. Well, guess what? In my next lab, I want to close the circuit and prove how OSPF works. The more we work with these labs, the better we're going to be starting understanding what OSPF. So we'll see you folks in our next lecture. Bye now. All right. Everybody, welcome back. It's Mo again. We're in this lecture. We're going to be still looking at OSPF. I'm going to be proving a point. The weight elects the best route, which is based on bandwidth. All right. So watch this. Let me get a few routers over here. This time I'm going to get a 2911. So let's say we have one router here, 2, 3, 4, and 5. Let me just get a larger image. Drag these down over here. Okay. So let's take a look and see over here. So let's say, let's call this NY. Same thing as before. NJ, PA, DE, Maryland, and Virginia. I actually chose a 2911 because they actually have 3 interfaces. All right. So watch this. So what I'm going to be doing is, let me just go ahead and put the actual cables. So from gigabit 01 to gigabit 01, gigabit 02 to gigabit 02, gigabit 01 to gigabit 01, gigabit 02 to gigabit 02, and gigabit 01 to gigabit 01. And from here to here, watch this, I'm going to put gigabit 02 to gigabit 02. I'm going to get myself an actual switch right over here. See this? So I have a switch right over here, and I'm going to have a switch right over here. Let's get another switch right over here. So I'm going to say that we'll have an actual, let's say, laptop here, and we'll be putting an actual server right over here. All right. So watch this. So let me connect the laptop to the switch and the server to the switch. And then I'm going to be getting a cable, of course, from gigabit 00 to the switch over here and also to this router over here, gigabit 00. All right. Let me put the actual networks in so we could simplify. So let's say this side is going to be the 192.168.10.0/24. And this private network will be 192.168.20.0/24. And I'm going to have this one as what? 210.210.210.0/30. And this one 211.211.211.0/30. And this one is 212.212.212.0/30. 213.213.213.0/30. And 214.214.214.0/30. And this one is going to be 215.215.15.0/30. So I have the networks right over here. So I could see which networks and the actual interfaces. So in case we make mistakes, we could actually look at this. Okay, so let me go to New York first, and let's go ahead to New York. So let me just log on and change the host name to NY, then interface gigabit 0/what? 0/0, right? So we're looking at the interface that connects to the switch. And I'm going to do no shut. See, it turned up, and the IP address is 192.168.10.254 space the default mask. Then I'm going to go to interface gigabit 0/1, which connects to New Jersey. No shut, and we'll give it an IP address as what? 210.210.210.1, 255.255.255.252. And then I'm going to do interface gigabit 0/2 and no shut. And this one will be what? 215. 215.215.215.2, 255.255.252, right? And then do WR. So I'm actually done with New York, as you see. This time we're going to go to NJ. And let's go ahead and change the host name first. So host name is NJ, then interface, let's say gigabit 0/1, no shut. This connects to NY. So the interface is up, and this will be 210.210.210.2, 255.255.255.252. All right. And then I'm going to do interface gigabit 0/2 and do no shut and do IP address as 211.211.211 dot what? 1, 255.255.255.252. And then I'm going to do WR. And then we're going to go to PA, right? So PA is our next one. Let me change the host name to PA interface gigabit 0/2. That connects to NJ. So I'm going to do a no shut and then do IP address 211.211.211.2 space 255.255.255.252. Okay. And then gigabit what? 0/1 and do the same thing. No shut and IP address is 212.212.212.1 space the 252. Right? And then do WR. So I'm done with PA as you see. Now we're looking at Delaware, right? So let's go ahead and log on and change the host name. Host name Delaware interface gigabit 0/what? 1, no shut. The interface is up. Very good. IP address 212.212.212.2, 255.255.255.252. And then interface gigabit 0/2 and no shut. And then IP address is what? 213, 213.1, 255.255.255.252, right? And then do WR. So that's Delaware, all right? Now we're looking at Maryland, which has 3 interfaces. As you see, that's how many interfaces are actually used. So let's say the host name is Maryland, and then interface gigabit 0/2, no shut, and let's give it an IP address as 213.213.213.2, 255.255.255.252. And then we're going to go interface gigabit 0/1, and then give it an IP address as 214.214.214.1, right? And this one also has a gigabit what, folks? 00. So interface gigabit 00, all right? No shut. And the IP address is 20.254. See how the interface goes up? Space the default mask here, right? And then do WR. And then Virginia, the last one. All right. And let me just change the host name to Virginia, and then interface gigabit 0/1, no shut. IP address is 214.214.214.2, 255.255.255.252. And then, of course, gigabit 0/2, no shut. And this will be 215, all right? Dot 215.215.1, 255.255.255.252, and do WR. And guess what? All the interfaces are up and running, all right? So this one will be, let's say, 10.100, and the gateway, which is the IP address of the router, 10.254. And this one over here will be 20.100, and the gateway is 20.254. So 20.100, and the gateway is 20.254. So if I try to reach to the server, watch this, of course, it's not going to work. So if I say ping -t, and I say 20.100, cannot reach resources. This router has no clue. This router only knows about the 10, 210, and 215. Look at this. So New York, if I do show IP route connected, only knows about these. So let me use OSPF. Watch this. So I'm going to do the same commands as I did before and advertise the networks that I actually support, which is 10.0, the wildcard, and the area. All right. And I'm going to do the same thing with what? With the 210 and the 215. 000. Remember, the wild card is 3 because the jump start is 4. -1 is a 3, and we belong to the same area, which is area 0. And then I'm going to do the actual, what, 215 network, 215, 215, 215.0.0.0.3 space area 0. And let me save my configuration. And let me go to NJ and do the networks there. So if I do show IP route connected, I could see what I need to advertise to my neighbors. Router OSPF, same process. And I advertise the networks themselves, which is 211.211.0.0.0.3 space, the area, and also the 210. And now when I do the 210, what's going to happen? It's going to establish a relationship, an adjacency, right? And let me do WR. Then I go to PA, which is 211 and 212. I like to see it, show IP route connected, right? So router OSPF 100, and let me advertise the 212, 212, 212.0.0.0.3 space area 0, and also the what? The 211, 211, 211.0.0.0.3 space area 0. And let me save my configuration. That's PA. Now Delaware is 212 and 213. Right. So show IP route connected. So let me go back. Router OSPF 100, and network is the same. So 213, 213, 213.0.0.0.3, right? Space area 0, and also the 212. 212.212.212.0.0.0.3 space area 0, and do WR. So that's Delaware. Maryland has 3 networks, as you see. So if I do show IP route connected, and I'm going to go to global configuration mode, and I'm going to do router space OSPF 100, and then network is what? 20.0, 0.0.0 dot what? 255, right? So this is dot 255. Remember when I actually did New York for the 10 network, I had to make it as what? 255 because it's not subnetted. All right. Okay, so these are the only two that are actually not 255s. And let me do the space, the area 0. Okay. And then network 214, 214, 214.0.0.0.3 space area 0, and also the 213. So I'm always advertising what I physically support, folks, right? Static routing, if you recall, you add whatever you support. Dynamic, static, you add whatever you're missing. By dynamic, you add whatever you support. Virginia, the last one is 214 and 215. Show IP route connected. So router OSPF 100 and network is 214, 214, 214.0.0.0.3 space area 0, and also the 215 space area 0. I'm actually done. So right now, if I go to New York, immediately it's going to establish the relationship. So watch this. Look how the other neighbor is going to kick in right now within 3 seconds. There you go. All right. So if I do show IP route, I could see everything is actually my list. I could do show IP route and look at just OSPF and see what I got via the neighbors. So some are coming via one neighbor and some are coming. So this is 215, 215, 215.1 is coming from this neighbor, right? And then I could see I'm going to be talking more about this. And then I have the 210, 210, 210.2, which is coming from New Jersey. If I check the ping over here, look, it's actually working. You see this? Once I finished, look, remember it was actually destination host unreachable, but look, it's replying. So it looks good. Well, guess what? What I want to do is I want to trace. I want to see the path that it takes, which is to 20.100. And take a look. It's going through 215 and then 214, then here. So it's going through who over here, folks? Look at this. It's going through 215. So it's taking this route, Virginia, then Maryland. So it looks like it's working like rip. I thought that doesn't work like that. I mean, it's based on minimum hops, but OSPF is based on bandwidth. But it's going 1, 2 hops. Look at this. You see that? The hops. And then it's reaching, so it's coming out of my router, going through what? Virginia, then it's reaching Maryland, then it's reaching the destination. That's how it's actually working. So it's taken, it looks like it's working like rip, but it's not. You know why? Because the cost is the same. The speed of the lines are all the same right now. If the speed of the lines are the same, then it's going to take the shortest hop. But look what I'm going to do. I'm going to do something tricky over here to show you about OSPF. So this is gigabit 02, right? Watch this. So I'm going to do show interface gigabit 0/2. All right. And I want you to focus over here and look at the actual speed that we're actually getting over here. So I'm looking at the actual speed. Look at the bandwidth. See the bandwidth? It's like, okay, you're getting a gig. Okay, that's fine. All of them are actually the same. I'm going to change the bandwidth. So watch this. Config T interface gigabit 0/2. And I'm going to use the bandwidth command and change it to 64 kilobits. Imagine an ISDN connection. I am changing it to 64 gigabits. So that's this one over here. Then I'm going to go to Virginia and do the same thing. Watch this. Interface gigabit 0/2 and change the bandwidth to 64. So this line is 64. The rest is all gig. Well, guess what's going to take the long path now? Watch this. So if I do the trace again, look what it's doing. Ah, it's taking the long way. You see this? It's going through who? New Jersey, Pennsylvania, Delaware. You see that? Then Maryland is taking the long route because I changed the bandwidth, and that's how OSPF works. So if I go to New York right now, remember I showed you the routing table over here? If I do show IP route again, watch this. So if I do show IP route and I do, let's say, OSPF. You see this? Now, all of them are going through who? 210, 210, 210.2 because the cost is better. Before, it was going through where? Look at this. Some were actually going through what? You see that? 215 and some through 210. All right, now I changed the bandwidth and now everything is taking the best path based on the cost, which is through 210, 210, 210.2, which is through here. It's not taking this route because the line over here is kind of slow and this one is a gig, right? So if I go back and I say, you know what, let me switch things the way they were before. So let me go to the interface and do the bandwidth command again. And I'm going to say no bandwidth. So if I do Control A and just say no bandwidth, if you do no, of course, it gets rid of it. And I do no bandwidth over here. Now I go back over here and I'm like, okay, can you run the tracer again? And which on there you go, went back to its original. Do you see how OSPF works? That's what I wanted to show you in this lecture. In our next lecture, we're going to still talk more about OSPF. OSPF never finishes. It's one of the longest actual routing protocols. So we'll see you folks in our next lecture. Bye now. All right. Hello, everybody. Welcome back. It's Mo again. Well, in this lecture, we're going to continue with our interesting routing protocol, OSPF. We did see and we proved that OSPF calculates the best route based on the best bandwidth, which means the speed of the lines. For example, let's say we go to New Jersey here, all right? And let me show you an interesting command here. Let's say show IP OSPF neighbors. Who are the neighbors of New Jersey? And look what it says. It says there's 215.215.215.2 and 212.212.212.1. Now, is it really true that 215.215.215.2, the neighbor of New Jersey? What is this IP address? This is 215.215.215.1. You see that? So I do have dot two on this side, right? This is dot two, but this one is 210.210.210 dot what? Dot one. Why did New Jersey elect this interface as a neighbor instead of who? Instead of this interface. And same thing. When I went back to Jersey and I see my neighbors 211.211.211.2, right? So I do see that it's 211.211.211.2. This is 211.211.211.2. So when I look at this, I'm like, okay, who is the actual neighbor? So I could see over here, these are the actual IPs, but as you see, this is the actual neighbor. And the other neighbor is 212.212.212.1. Now, who's 212.212.212.1? It's this interface. It's not choosing this one. How does OSPF work? OSPF calculates the actual neighbor by default based on the highest IP address of the router. Now, who is the neighbor of NJ? It's NY. What's a higher IP address, the 210 or the 215? So the 215 became the actual router ID, which means this is the interface that advertises, which is not a good thing. And if I go back over here, who is my actual neighbor? Yes, it is PA, but it's using the highest IP address, which is 212.212.212.1. This is a designated router, which means, and then I have a backup designated router. This is the one that sends and receives updates. And in case it fails, I have a backup one. But check this out. This is not how it should be actually done. For example, let me give you another example. Here's Delaware. Who's the neighbors of Delaware? It's Maryland and Pennsylvania. So before I do it, I'm going to see if it's Pennsylvania. What's the higher IP address? 211 or 212? It's 212. So 212.212.212.1 will be one of the neighbors. And Maryland is another neighbor. What is the higher IP? 213 or 214? It's going to be the 214. So watch this. So if I do show IP OSPF neighbors, I can see what I just told you, 214, 214, 214.1. This is not correct. You know why? What I need to do is over here, I need to build something, right? So I need to build something called what? Router ID manually. Now there's other options. If you don't configure the router ID manually, the highest IP address will become the RID. So what I need to do is this. Let's go to New York first of all. Watch this. So I could configure something called the loopback interface, which is a logical interface. It's a fake interface. And the loopback automatically becomes the router ID of that router itself. That's one thing that I could do. Let me show you that. So I could say interface, loopback, let's say 0, and give it an IP address. Let's say a class A, 10.1.1.1, and let's say the 3255s, using it as subnetting. And I don't have to do a no shut. And I go to NJ and I'll make it as what? 10.222. Interface loopback 0, and I give it an IP address as 10.2.2.2. So the loopback right now becomes the router ID. Okay. If I go to PA, just to show you, when I do show IP OSPF in general, I can see who the router ID is. You see that? It's the highest IP address of the router. I could do show IP protocols, and I could see the RIDs themselves. And this is not correct. This is not something that we need. We need to put a fake interface to advertise in case something happens with a real interface. So NJ is actually done, and this will be 10.333. So interface loopback 0, and I do IP address 10.3.3.3 space 255.255.255.0. And this one will be 10.444. Interface loopback 0 and IP address 10.4.4.4 space dot 0. And this one will be 10.555 for the loopback. So the loopback becomes the router ID. If you don't configure that, then the highest IP address will become the RID. 10.555 space 255.255.0. So this is 1, 2, 3, 4, 5, and this one will be actually 6. So the loopback becomes the advertising interface, basically. 10.666, 255, 255, 255.0. Let me do a WR on each one of them, because in case I need to reload, right, I'm not going to lose the actual configuration. And here's WR and do WR. And right over here, do WR. Okay, so if I power cycle and click yes, and fast forward and go to NJ right now, see, look who the neighbors are. It's the actual loopback. You see that? So if I do show IP OSPF neighbor, I'm not going to see the highest IP address. It's going to be the loopback that I configured. Who's 10.1.1.1? It's this router. And who's 10.3.3.3? It's this router. So if I go to Delaware, watch this, and I do the same thing, show IP OSPF neighbors, I actually see 10.3.3.3 and 10.5.5.5. So this is 3.3.3.3 and this is 5.5.5.5. So when you configure loopback, the loopback becomes the actual what? Router ID instead of the highest IP address of the router. So if I do show IP protocols, I can see that now it's the loopback interface. You see that? That's a router ID. This is one way. So if you don't configure a loopback, the highest IP address of the router becomes the RID. That's the advertising interface. What I could also do, I can configure the RID manually. The router ID can be configured manually instead of electing the actual loopback interface. So what does that mean? If I go back to New York, and I say router OSPF 100, and then I ask for help, and I should have an actual command called the router ID. So I can configure the router ID manually and give it an actual IP address. Let's say 172. I'm going to do it higher than the loopback to show you that this will take effect. 16, let's say 1.1, 255.255.0.0. I don't actually have to put a subnet mask. That's correct. So if I put question mark, it's enter. Now look what it says. If you want to do this, you have to clear the IP OSPF process, run this command to reset it so it could take effect of whoever's actually the RID right now. And I'll be running this command later on. So this is 16.1.1. And let me go back here. Router OSPF 100. And the router ID is 172.16.2.2. See, it tells me to run that command. Pennsylvania. So this one right now, the router ID command overwrites the loopback, and this will become the advertising interface, and this is what's actually recommended. Router OSPF 100, and then the router ID 16.3.3. All right. And so this is 3.3, and this one will be what? 4.4. Router OSPF 100. And I'm going to do the router ID command 172.16.4.4, right? And this one will be 5.5. Router OSPF 100. And the router ID is 172.16.5.5. 1, 2, 3, 4, 5. And this will be 6.6. router OSPF 100, and the router ID is 6.6. And it tells me to run this command, which means I have to run clear IP. You see this command, OSPF, and then the what? The process, IP, OSPF, and the process, and reset. Now, you don't do this during production time, just to let you know. See, it tells you, are you sure you want to do this? See, the neighbors go down. You see that? Then it loads them again. So this, it loads the neighbors again. So this is not something that you ever actually want to do during production time. And let me do it here. I could reload the routers. This is a command that I could do. Clear IP OSPF process. And I'm going to say yes. And same thing over here. Clear IP OSPF process and say yes. Clear IP OSPF process and yes. And NJ. Clear IP OSPF process. And yes. And NY. Clear IP OSPF process. And yes. There we go. So this is how it's done. Now, if I go back to New York, look, it went back, it loaded it. See, loading to full right now. So this is actually a good sign. See how it was actually down? Because I did the reset over here. So now it's going to load back what? Up and running. So what I'm going to be doing right now is I'm going to run the show IP OSPF neighbor. And look, see the router ID becomes the advertising, not the loopback. So if you configure something like this, the loopback is actually taken over. So if you configure the loopback, that overwrites the highest IP address. But then if you configure the router ID command, that overwrites also what, folks? The loopback, show IP OSPF neighbor. So I'm back in business. See that? Or I could do show IP protocols and I could see right now. I mean, if I reset, the others will be gone. But look, take a look. See, that's the one who's advertising. Instead of the loopback, instead of the highest IP address, this is what's recommended is when you configure the router ID. That's what I want to show you in this section. So when I run actually any debug commands to see what happens in the background, let's say debug IP OSPF, and let's say adjacencies is turned on, right? I'm going to see the actual what? The one that I configured, which is the router ID itself. Now, of course, I could reach from any side to any side, and I could do also the events, right? Events. There we go. So events is actually done too. This is one thing. So it may take a few seconds. Now, a reason why these two neighbors establish a relationship because they belong to the same what, folks? Same area. So they all belong to the same area. You see that? Look, received hello, received hello. You see that? It's coming from the one that I configured as the router ID. We're going to be talking about these hello packets. All right. All right. The way that actually works, there's timers that we're going to be mentioning. That's what we're going to do in our next lecture. That's what I wanted to show you here. Once OSPF is configured with the areas, you must configure the router ID, which means this is the one that's going to be advertising to the neighbors instead of the real physical interface or instead of the what? The loopback interface. So we'll see you folks in our next lecture. Bye now. All right. Hello, everybody. Welcome back. It's Mo again. Well, in this lecture, we're going to still continue with OSPF, but this time we're going to be talking about the timers. As you see, little by little, we are building up how OSPF works and the proper method of configuring OSPF. Now, watch this. Let's say, why did New Jersey establish a relationship with PA and with New York? Well, first of all, they belong to the same area, which is Area 0. If it's a different area, then they won't be able to talk to each other. And another example, like, why is it working? Because they have the same timers. What timers are we actually talking about? Let's take a look and see. So let's say I go to NJ, right? And let's see. Let me stop the debugging over here. All right. So let's say undebug space all. Okay. So if I do show IP OSPF interface gigabit 0/1, look at this. I do see who the router ID is. I could see the IP address. It's a broadcast. But look, the hello time is 10 seconds. Every 10 seconds is like, hello, are you there? I just want to make sure you're there. If there's any changes, I'm going to go ahead and send updates to you. That's how OSPF works. How does it work? Through something called LSA, which is a link state advertisements. It goes into link state packets. Just tell it like, okay, I have something new. I know about a new network. This network was removed. It does this every 10 seconds. It doesn't send them routing table. It just says, are you there? Are you alive? Every 10 seconds. I just want to make sure you're there just in case there's any changes. I will tell you the increments. The first time that we establish a relationship, what's going to happen? I'm going to send you my complete routing table. And after that, I'll be just checking on you. Are you okay? Every 10 seconds. Now, if I don't hear within 40 seconds, you'll be removed as an actual neighbor. Now, guess what? These timers have to match on the routers. If they don't match, you're going to be losing a relationship. For example, I'm going to do it on NJ. So, NJ, I'm going to do it on both interfaces, and you'll see I'll be losing the relationship with PA and Y. Watch this. So if I go ahead to global configuration mode, interface, let's say gigabit 0/1, IP OSPF, and I'm going to look at the actual what? The hello interval. You see that? Now look, the hello is 10, the dead is 4. So it's like a 30-second difference between them. So I'm going to say the hello interval, and I'm going to ask for help. And anything that you get from Cisco, by the way, never ever change it. Just stick to the actual same. So I'm going to go ahead and make this as 30. Okay. Just like this. So I'm making this as 30 seconds. I'm only going to mess around with the hello. I'm not going to touch the dead just to show you. But normally, if I do this, I should change the dead interval also. So I'm going to do the dead interval also. IP OSPF, dead interval. So by default, I had a 10 and I made this as a 30. I'm going to make this as a what? As a 60, let's say. So as you see, I should try and match the differences between them. So there's 30 between them. And I'm going to make 30 between this, which is an actual 60. And then I'm going to go to the other interface, which is gigabit 00, right? And do the same thing. Or it's actually gigabit 00 or gigabit 01, 02. So I did 01. Look, immediately I lost the neighbor. You see that? And I'm going to do gigabit 0/2 and do the same thing. Hit the up arrow and the hello for 30. And the dead is also for what? Let's say 60. And look how I'm going to lose the neighbor. It went down. Watch this. Within 10 seconds, it's like, hello, I have no clue. Where are my neighbors? I just lost both of my neighbors because I'm not matching the hello and the dead intervals. So the hello and the dead intervals have to actually what, folks? They have to match. So I lost one from 172.16.1.1, which is which one? This one. Now I'm going to lose it from where? 3.3. That's the one that I'm going to be losing right now in a few seconds. There you go. I just lost it. Why? And look, if I do show IP, OSPF, neighbors, I see no neighbors. If I do show IP route, I don't see the OSPF. I lost everything because I'm not matching the hello and the dead timers. That's what I need to match. So I need to match the hello and the dead timer. So I'm going to go back and say interface gigabit 0/1. And I'm going to say hit the up arrow and just do a no in front of it. Where you see this? And same thing for what? The dead timers and control A and just do no in front of it. And I'm going to do the same thing for gigabit 02. So it's like I never did anything right now. And I'm going to do the one with the 30 seconds. I'm going to get my business back up and running right now. So it's going to stop. There you go. Hello. It's loading to full. Everything looks fine from one neighbor. And now I'm going to see the other neighbor and it's going to do the same thing. So remember, I have to match the area and I have to have the same timers for the hello and the dead timers. If I don't, I would lose connectivity. So if I do show IP OSPF neighbors, now I see everything. And if I do show IP route, now look at this. I got all the O's back in business, which is OSPF. That's what I have. So right now, OSPF is back in business, as you see. So that's one thing to keep in mind. So that's what I wanted to show you in this lecture. In our next lecture, I want to show you more labs about OSPF, especially security. How can I secure connections? Right now, OSPF is not secure. I want to show you how that's done. So we'll see you folks in our next lecture. Bye now. All right. Well, everybody, welcome back. It's Mo again. Well, in this lecture, we're still working with OSPF, and what we're going to be looking at over here is how can I secure OSPF? By default, OSPF, there's no security for it, so I want to do some type of what? Authentication, for example. Again, as we said, New Jersey was establishing a relationship with PA and NY because they belong to the same area and they have the same timers, right? Well, watch this. Look what I'm going to do over here. I'm going to go to NJ. Now, look, if I go to PA, all right, and I say show IP OSPF neighbors, I can see 2.2, which is actually NJ, right? So I could see that. And if I go to NY and I say show IP OSPF neighbor, I can see 2.2. That's another one I could see. Okay, so what I'm going to do right now is this. I'm going to go to NJ. I have gigabit 01 and gigabit 02. All right, so this is what I actually have. Okay, so watch this. Interface, gigabit 0/1. I'm going to do the IP. OSPF, there's a command called the authentication. Enabling the authentication. You see this? Authentication question mark, enter. Then I'm going to do the IPOSPF authentication dash key and come up with a key, and I'll just call it Cisco and press enter. And I'm going to do the same thing for which interface? Gigabit 02, authentication, and the key, which is Cisco. So I only enabled authentication that you have to come up with this shared key, which is symmetric encryption, and that's actually Cisco. All right. So look what's going to happen right now. Watch this. I'm going to be losing my neighbors because look, I'm losing one neighbor, the 1.1. Look, it's down, interface down, and I'm going to lose the other because they never authenticated with the same shared key. So I'm doing this for extra security right now. And I'm going to lose the other neighbor, which is what, folks? 3.3 within a few seconds. One, two, there you go. See that? So I lost that. So if I'm actually on NJ right now and I do show IP routes, you see this? I see nothing about OSPF. So I have to go to PA and I have to go to NY and configure the authentication on each one of them. So let me fix PA, for example. All right. So watch this. So if I go over here and I say interface gigabit 0/1 and IP OSPF authentication, right? And then authentication key, which is Cisco, right? And then I do gigabit 0/2, and I do IPS authentication and the key, which is Cisco. I'm going to be back in business. So New Jersey is going to tell me right now, listen, 3.3 is going to be back in business. There you go. You see that? Okay, very good. And I'm going to go to New York and do the same thing. So watch this. Interface, gigabit 0/1, IP OSPF authentication, and then I'm going to do the actual key, which is Cisco. And now I'm going to get the neighbor. Watch how I'm going to get the other neighbor, which is 1.1. Come on, one, two, three, and let's kick in. There we go. I'm back in business. You see this? So if I do show IP route, I can see my networks now. I'm back in business, as you see. So another thing that we could do, I should go and do it on each route, as you see. I need to do authentication, and I specify the key, which means if you don't authenticate with that key, you will not be able to establish a relationship with me, even though you belong to the same area and you have the same timers and all of that. This is a good thing about what, folks? OSPF. All right. That's what I want to talk about. So we'll see you folks in our next lecture. Bye now. All right. Hey, everybody, welcome back. It's Mo again. Well, in this lecture, we're going to be looking at is another lab for OSPF. Do you recall when we said how do routers become adjacencies? How do they become in a relationship because they're sharing the same what? That timer, the hello timer, they're sharing the same area. So let's say I don't want two routers to talk to each other. I can put them in different areas. Let's say for a large network. I don't want everybody to be in the same area, which means they're not going to be sharing the routing table so I can put them in different areas. Now, if two routers and they're still physically connected with each other and they belong to a different area, they will not form an adjacency. For example, so if I go back to New Jersey, let's say, watch this. When I do show IP OSPF neighbors, I could see both neighbors. I could see the neighbor as 1.1, which is New York, and I could see 3.3, which is Pennsylvania. But watch this. Look at this. This is gigabit 02 and this is gigabit 01. So let's say I want to get rid of OSPF. Watch this. So let's say no router OSPF 100, and this time I do router OSPF 100, right? And I do the networks again. So I'm going to be advertising the networks that I support, which is the 210 and the 211, right? So this time, look what I'm going to be doing. 192, let's say 210.210.210 dot what? Dot zero space 000.3 space. This time, I'm not going to use area zero. We're going to put area one. And also, I'm going to be advertising the 211.0, right? So look at this. It's like must be in the same, not found. It's like invalid. Do you see this? I mean, it knows immediately that something is actually what? Wrong. So let me run this command 0.0.0.3 space what? Area one. So it already knows, like, listen, there's a mismatch. You don't belong to the same area. So let me do Control Z and do show IP OSPF neighbors. And I'm not going to see any neighbors at all because there's a mismatch area, as you see. So what I could do is I could go to Pennsylvania, which is 211 and 212, just to show you how I could actually fix this. You see that? The area is no good. Okay, so what I'm going to do is no router OSPF 100. And then I'm going to do router OSPF 100. Then I'm going to do the networks, which is what? 211 and 212. 211.0.0.0.3 space area what? 1 and also the 212. Let's say 212.0.0.0.3 space area 1. Now it says, hello, there's an actual area. You see that? I got this error message because the 212.212.212 is connected to this router, and this router is in area 0, and this one is in area 1. So I have to go over here and change this also to what? To area 1. So this proves to you for routers to become neighbors, they have to be in the same area, they have to have the same timers, and you must configure the router ID. So these are the requirements for OSPF. As for, like, let's say the cost over here, when I do show IP, let's say route OSPF, I can see the cost, like some is 3, some is 2. By default, the cost is 1. So if I do show interface, let's say OSPF interface, let's say gigabit 0 slash let's say 1 space question mark. I'm looking at this interface and I can see, okay, what IP address that I actually have on the system itself. Remember, I did not touch the actual what? The bandwidth, which is the actual speed, right? And it tells me, okay, it's full duplex and all that. But if I do show IP OSPF interface and I do gigabit 0 slash 1, I can see that the cost is 1. So by default, cost is 1 on all of them. And the reason why you would see the cost is 2 or 3 here, which means every time it passes through a router, that's 1, that's 2, that's 3. It's like adding the cost to it. And the default cost is 1. And that could be actually modified. But as you saw that I was able to change the bandwidth, which is the speed of the lines. That's what I wanted to show you in this lecture. In our next lecture, we're going to be starting with what? With EIGRP. We'll see you folks in our next lecture. Bye now. All right. Hello, everybody. Welcome back. It's Mo again. Well, in this lecture, we're going to be looking at as EIGRP. As you saw, we looked at RIP, OSPF, and both of those routing protocols, they work on Cisco and non-Cisco routers. RIP's administrative distance is 120. The maximum hops is what, 15? It's based on timers, where OSPF is unlimited on hops and the administrative distance is 110. As you see, it's more trustworthy, but there's no timers. There's only like hello packets every 10 seconds for OSPF. So if I configure both RIP and OSPF, of course, OSPF will take effect in the routing table. Now we're looking at EIGRP, which only works on Cisco routers. And it's the most trustworthiness, which means the administrative distance is actually 90. So let's take a look. I'm going to get a few routers. So let's say 1, 2, 3, 4, and 5. Just 5 routers. Now let me just move these right over here, align them correctly. And I'm going to get a switch on this side and a switch right over here and see how does EIGRP actually work. A laptop here, and let's say a server here. Let me give the names. Let's say we got New York, NJ, PA, Delaware, and Maryland. Now let me just make the actual connections. So let me connect, first of all, the laptop to the switch and the server to the switch, as you see. And now let me make the connections from here to here. Let's say gigabit 00 goes to the switch and gigabit 00 goes to the switch right over here. Now I'm going to be using crossover cables. So gigabit 01 to gigabit 01, 00 to 00, 01 to 0, let's say 1, and 00 to, let's say 01. And let me put the actual networks. So let's say this one is going to be on the 192.168.100.0/24. And this one over here is going to be on the 200.0/24. And this network will be, let's say 210, which is a public IP, .0/30. And this one is going to be 211.211.211.0/30. And we got 212.212.212.0/30 and 213. dot 213.213.0/30, just like that. Now, let me go to each router. First of all, I just want to put IPs and change the host name. I know we saw this a lot, but the more you practice, the better you actually get at this. So let's say interface gigabit 00, which is IP address is 100.254. Space the default subnet mask, and then I'm going to do no shut. And then interface gigabit 0/1, no shut, right? And the IP address will be 210.210.210.1, space what? 255.255.255.252. And let's do WR. And back to MJ. Change the host name to NJ, and then interface gigabit 0/1, which connects to NY, all right? IP address is 210.210.210.2, space 255.255.255.252, and no shut. And then interface gigabit 0/what? 0. And I'm going to do no shut, and IP address will be what? 211? Dot 211, dot 211, dot what? Dot 1, 255, 255, 255, 252, and do WR. So if I maneuver the mouse here, I could see the IP address of each one of them, right? And same thing right over here. Now let's go to PA. And let's do this. And global configuration mode, host name is PA, interface. Let's say at the beginning, I'm going to do gigabit 00. All right, gigabit 00, and do no shut. Give it an IP address as 211, 211, 211.2, 255, 255, 255 dot what? Dot 252, right? Because it's a slash what? 30. And I'm going to do a no shut. And then I'm going to do also what? Which interface? Gigabit 0/1, no shut. And that's 212. So IP address is 212.212.212.2. Is it 2 or 1? It's actually 1. All right, 255, 255, 255.252, and do WR. And let's go to Delaware and do no. Let's go back to global configuration mode. Host name is Delaware. Interface what? Let's say gigabit 0/1 first. No shut. Interface is up. And it'll be 212. 212.212.2, 255, 255, 252, right? And then I'm going to do a gigabit 00 and do no shut. IP address 213, 213, 213.1, 255, 255, 255.252, right? And let me do WR. So that's Delaware. And now I'm going to go to Maryland. And I'm going to go ahead and change the host name first. So host name is Maryland and interface gigabit 0/1 and do no shut. and IP address is 213.213.2, 255.255.255.252, and then interface gigabit 0/0 and do normal. And the IP address here is 200.254, right? 192.168.200.254 space the default mask and do WR. So we're done putting the IPs. Everything is up. I'm going to make this as 100.100. So 192.168.100.100. And the gateway is the IP of the router, which is 100.254. And this one will be, let's say, 200.200. All right. And let's take a look. 192.168.200.200. And the gateway is 200.254. Close and close. If I try to reach from the laptop to the server, I can't, right? Let's just verify that. 200.200. Unreachable. New York only knows about the 100 and the 210. It has no clue about the other networks. So my duty is to configure EIGRP, which only works on Cisco routers. Now it's very simple configuration. EIGRP is based on bandwidth and delay, where OSPF is based on bandwidth and RIP is based on minimum hops. EIGRP is considered as a what? An advanced distance vector protocol. Like RIP is a distance vector protocol where OSPF is what? Link state. And EIGRP is an advanced distance vector protocol. It's like a little bit as a hybrid, I would say so. Now, what's most likely in today's field you would be seeing as OSPF. EIGRP is recommended if you're just dealing with Cisco vendors. So if I go ahead and do show IP route connected, I can see these. So how do I configure EIGRP? Router EIGRP, we have to come up with something called an eponymous system number. Think about it as an area for OSPF, and they all have to match the same autonomous system number to become neighbors. So I'm going to come up with a number 100 and advertise my networks, which is 100.0. And if I put a question mark, I have to put the wildcard, which is 000.255. And then I do the other network, which is the 210, 210, 210, 210.000.0.3. And then that's it. There's no areas over here. You see that just like this? And I like to put a passive interface on which one of them? On interface gigabit 00, because I'm not going to be actually sending updates during that way, just like OSPF and RIP. So I want to do that right now. Let's say gigabit 0/0. All right. Just like this. If I put a question mark, I can see all the commands that I could actually do over here. As you see, I could change the distance. I could do all of that. So I'm going to do WR and minimize this and go to NJ and do the same thing. So show IP route connected, and let me advertise my networks. Router EIGRP 100. So I have to have the same anonymous sys number for them to become neighbors. EIGRP uses a protocol called RTP to exchange routes from one neighbor to actually another. It uses an algorithm called dual, which is diffusion update algorithm, which is based on bandwidth and delay. So let me advertise my networks 211.211.211.0.0.0 dot what? Dot 3. And also the 210. Look what's going to happen when I do the 210. It's so quick. It's quicker than OSPF. Watch this. Look, when I press enter, it's going to tell me, listen, there's a neighbor. Right away, there's a neighbor. You see how quick? Cisco made their own protocol. And let me go to PA and do the same thing. Okay, show IP route connected. So I'm going to do router, EIGRP 100, and do the networks. 212, 212, 212.0.0.0.0 dot what? 3, and also what? 211, 211.211.211.0.0.0.0 dot what? Dot 3. And now look, the neighbor is established because they're using the same what? Anonymous system number. So this one over here is 212 and 213. Show IP route connected. So router, EIGRP 100, and then network is what? 213, 213, 213.0, 0.0.0.3, and also what? 212, 212.212.212.0.0.0.3. And now the neighbor is actually established. You see that? And now I'm going to go to Maryland and do the same thing. But look, this machine is still not reaching because I have no clue about all the networks. So this is my last router, show IP route connected, router, EIGRP 100, and then the networks. 192.168.200.0.000.255, right? That's full, all right? And the 213. 00.3. Now look, the neighbor's established. And look how quick, look at the speed right now. It's going to ping immediately. Watch. One, two, three. I am going to get a reply. There we go. Now I could reach. So if I try to trace her, 192.168.200.200 is going to tell me the path that it's actually taking. These are the routes that it's actually going through. If I try to trace from here, let's say, right? It's called trace route. Remember, 192.168.200.200 is going to tell me the path that it's actually taking. So if I go back to New York and I say, okay, go IP route, I'm going to see the letter D for diffusion update algorithm. That's EIGRP, and this is administrative distance. And this is the actual bandwidth and delay, as you see. So the letter D, as you see. I could do show IP route EIGRP, and I can see all of them there. If I do show IP protocols, I can see that I'm only running what? EIGRP. These are the metrics that I'm actually using. So as you see, I could tell that, okay, the administrative distance is 90. If it's external, like a different autonomous system number, it'll be actually 170. And I can see which networks I'm actually supporting over here, as you see. So these are the values based on bandwidth and delay. So that's how EIGRP actually works. That's what I wanted to show you in this lecture. In our next lecture, we're going to start doing a lot of manipulation. So remember, I would have to do the passive interface the way I did it over here. Remember when I did the passive interface? So technically speaking, I would have to run this command on the rest of the routers. Do I have to do them here? No, I have to do it on Maryland. So Maryland, I would do a passive interface on what? Gigabit 0/0. The other ones I don't because I need to send and receive updates. But this one, I don't need to send updates because there's no routers here, no routers here. So passive interface here and passive interface here. That's what I want to show you in this lecture. In our next lecture, we will continue our interesting journey with EIGRP. So we'll see you folks in our next lecture. Bye now. All right. All right, folks, let's go ahead and continue. It's small again. Watch this. What I'm going to do is the following. I just want to show you a few things. Let's say I go to NJ and I do this show IP EIGRP neighbors. I can see my actual neighbors. And you see this? So, for example, NJ has what? Look at this 210, 210, 210 dot what? Dot one and 211, 211, 211 dot two. So these are the actual neighbors through what interfaces? Smooth the round trip time. The Q is zero, which means, okay, everything's actually perfect. So these are my actual neighbors themselves. What I want to do is actually the following. If I do throw run, I can see EIGRP is actually what? Running. And it's using this autonomous system number. I want to prove a point over here. So let's say PA is the main focal point. So I'm going to say this side to here is going to be using autonomous system number of 100. And then this side will be what? Using 200. And let's see what's going to actually happen if I have different ones. So the only thing I have to do over here is go to PA, go to router, EIGRP 100, and do no network, right? Watch this. No network, 212. 212.212.212.0.000.3. Now it says it's down. You see this? Now I'm going to do router EIGRP what? 200 and put this on the different autonomous system number and show you what's going to happen. 0.0.3 and enter. And then do WR. So this side is 100. Now this side is going to be all 200. So I have to go to what? Delaware and get, look, it says expired. You see that? No router EIGRP, let's say 100. And I'm going to do router EIGRP 200 and advertise my networks, which is what? Let's say 213, 213, 213.0.0.0.3, and also the 212. 212, 212, 212.0.0.0.3. Now it says, okay, formed a relationship. Very good. All right. And now I'm going to go to Maryland and do the same thing. See, it says expired because it's a different autonomous system number. So no router, EIGRP 100. Then I'm going to do router, EIGRP what? 200, and advertise my networks, which is 200.0.000.255, and also which one? The 213.213.213.0.0.0.0 dot what? Dot 3, and do WR. So if I notice something right now, from this side to here is using autonomous system number 100, and this one is using what? 200. So what does that mean? If I go to New York, watch this, and I do show run, I can still see the same information. Autonomous system number is what over here is actually 100. So if I do show IP route, and EIGRP, look what I see. I only see the 211 so far. Why do I see the 211? I'm not going to see the 212. I'm not going to see the 213. Why? Because these belong to what? To autonomous system number 100. If I go to Maryland, let's say, and I do show IP route EIGRP, I'm only going to see the what? Look at this. See that? I just see the 212, which is this one. I don't see the 210, 211, or this one because Maryland belongs to which autonomous number? 200, and only 200 belongs to these networks. So the only thing that I'm going to see is 212, and New York is only going to be seeing 211. So what does NJ see? Is only going to see the 100, right? So look at this. Show IP route EIGRP, only the 100. If I do show IP route in general, look what I see. I am missing the 212, 213, right? Because, and also the 200 because it's a different autonomous system number. If I go to Delaware, Delaware is only going to see 200. It's not going to see the 210, 211, and the 100 because it's a different autonomous system number. Now, why am I actually doing this? Watch this. Swipe throughout. See that? Just like this. I am missing the other networks, the 210, the 211, and the 100 network. But Pennsylvania supports both. Look at this. Show run. Watch this, folks. So Pennsylvania supports the 100 and the 200. So when I do show IP route over here, I see everybody. Do you see that? So let's say Pennsylvania is the headquarter. I could access every network because I support both autonomous system numbers. If you just support the 200, you're only going to see what's actually in the 200 by default. But I could do some type of redistribution where I could actually see that. But the purpose of me putting different autonomous system numbers so I could actually separate the traffic. I want Pennsylvania to reach everybody, but I just want New York to reach only up to here. And I want Maryland only to reach up to here. So I'm doing restrictions over here, but Pennsylvania is a headquarter. It could reach all the networks because it supports both autonomous system numbers. So when I do show IP protocols over here, I can see 100, I can see which network, and I also see what 200. I see both are actually in the list. That's what I want to show you in this lecture. To let you know, for two routers to exchange, they have to be using the same autonomous system number, right? If they don't, they will not become neighbors, they will not exchange. But Pennsylvania supports both, which means Pennsylvania will be able to reach what? All the networks. That's what I want to show you in this lecture. So we'll see you folks in our next lecture. Bye now. All right. Hello, everybody. Welcome back. It's Mo again. Well, in this lecture, I'm going to be configuring three types of routing protocols and see how that actually works out with us. But before I do that, I want to go back to Pennsylvania. I want to make everything as autonomous system number as what? As 100. So let me look at my actual configuration. So I'm going to get rid of the 200 and add it to the 100. All right, so watch this. So I'm going to say no router EIGRP 200. Then I'm going to say router EIGRP 200 and advertise my network, which is the 212. 212, 212, 212.0.0.0.3, right? Just like that. All right. And then I'm going to do WR. And I'm going to go to Delaware and Maryland and make them as the 100. So I'm going to go ahead and do no router EIGRP 200, then router EIGRP to 100, and advertise my networks, which is what? The 213.213.213.0.0.0.3, and also the 212. 212.0 space 000.3, just like that. So I actually have that, all right? So I'm doing everything as the 100, and I'm going to do WR, and then I'm going to go to Maryland and do the same thing. No router, EIGRP 200, then router EIGRP 100, and advertise my networks, which is the 192.168.200.0.000.255, and also the 213, 0.0.3, just like that, and do WR. So if I look at my running configuration, I should see that I have the 100 for this one over here. All right, so this is actually fine. That's what I just actually advertised, as you see, right? Okay. And let me go back to Delaware and do the same thing and show run so I could see that I'm advertising the 100. So everything looks fine. So right now, this machine should be able to reach everything. Let me just run the trace, make sure it goes through. Should take effect immediately. It looks like it's actually stopping. Something is going on over here. Okay, can I ping it? No, it's unreachable. Okay, let's take a look and see why. Let me go to New York and take a look and see. So if I do show IP route, I only see this. I only see the actual, that one. Okay, let me go to NJ and show IP route. Show IP route. Okay, I only see one. Let me go to Pennsylvania. Looks like Pennsylvania is our problem. It's retrying. Let's take a look and see. So, okay, it looks like Pennsylvania, I did not remove the 200. So let me go ahead and do no router EIGRP 200, and then router EIGRP 100 and advertise the network, which is a 212. Okay, this will fix it. 212.212.0.0.0.3. There you go. The neighbor is actually fixed. WR. And let me take a look and see if the ping is going to go through. There you go. It's pinging right now. All right. So if I go to New York and show IP route, I could see everything. So of course, this is running 90 as administrative distance. Now let's say in New York, show IP route connected, and I want to configure OSPF. I don't want to configure RIP. RIP is not something you'll ever actually choose. So let me go to config T, router OSPF, let's say 100, and advertise my networks. Let's say 100.0, 0.0.0.255 in area 0, and also the 210. 210.210.210.0.0.0.3 area 0, and then do WR. And I should put also a no passive, I should put a passive interface on which one? On gigabit 00, because it's the first one, right? Which is gigabit 00. Remember, that's something that we should actually do. 0/0. Okay, then do WR. Then I go to NJ and I'm going to be advertising the 210 and the 211. So I like to do show IP route connected. Router OSPF 100 and then advertise the networks 211, 211, 211.0.0.0.3 space area 0. And then 210, 210, 210, 210.0.0.0.0 space area 0. There you go. And do WR. Okay. And then I'm going to go to Pennsylvania and do the same thing. Show IP route connected. Router, OSPF 100, and then the networks. 212, 212, 212.0.0.0.3 space area 0 and 211. 211.211.211.0.0.0.0 space area 0 and do WR. All right. And Delaware. All right. So let's do show IP route connected and advertise these through OSPF router space OSPF 100 network 213 213 213 0.0.0.0.3 area 0 and also the 212 212 212 212.0.0.0.0.3 space area 0 and then do WR. and Maryland. Show IP route connected. Router OSPF 100 and advertise the networks. 192.168.200.0.000.255, area 0, and network 213.213.213.0.0.0.0, area 0. Just like that, and do WR. Now, I have EIGRP and OSPF running at the same time, but guess what? EIGRP is going to win. But look at this. If I do show IP protocols, I could see EIGRP and OSPF actually running. All right. I did not configure router ID. That's fine. I'm just going to do this live for the sake of who's actually taking effect. So if I do show IP route, I could see that EIGRP is taking effect. If I wanted OSPF to take effect, I could either lower OSPF than 90 or higher EIGRP than what? 110. So I'm going to say router, OSPF 100, and change the distance to, let's say, 88. All right. Watch this. And I'm going to go to New Jersey and do the same thing. Let's say router, OSPF 100, and change the distance to 88 in Pennsylvania. Router, OSPF 100, and change the distance to 88. And Delaware, exit, router, OSPF 100, and change the distance to 88. And same thing over here. Router, OSPF 100, and change the distance to 88. So now I change the distance to 88. So when I do show IP route, OSPF is going to take effect. And you see that? No longer EIGRP. EIGRP will take effect if something goes wrong with OSPF. So if I do show IP route again, I'll see OSPF. Sorry, show IP route. Now it's OSPF. And if I try the ping, everything looks fine. I'm still in business. That's what I wanted to show you. It's always good to have a combination of two routing protocols. Like EIGRP and OSPF is a good combination, by the way. That's what I wanted to show you in this lecture. So we'll see you folks in our next lecture. Bye now. All right.